This is Beyond the Business.
Today, I'm starting season 3 of Beyond the Business. This season is called The Ocean of Waste. And before anything else, I want to set the stage properly. Not with a headline and not with a warning, but with a simple reset. Because most of the time we talk about the ocean the way we talk about a view, a beautiful background, a place somewhere out there. But the ocean is not the background. So let's start with the simplest question and take it seriously. What is the ocean? In scientific terms, the ocean is a living physical and chemical engine. It's not only water, it's motion, pressure, temperature, salt, and time. It absorbs heat and holds it like a giant thermal memory. It releases that heat slowly, reshaping weather patterns, seasons, and climate across the planet. The ocean is layered. The surface can feel familiar, almost gentle. But a few meters down, conditions change. Deeper still, the ocean becomes a different world entirely. Colder, darker, heavier. And through all of it, the ocean moves. Not like a river you can point at, but like a slow, invisible circulation that carries energy and matter across vast distances. Sometimes that movement is quick and obvious. More often, it's quiet, patient, and powerful in a way that only shows itself over the years. Even when the surface looks calm, the ocean is still working. It mixes, it dissolves, it transports, it stores, it reacts. And the key word here is reacts, because nothing that enters the ocean arrives in a neutral space. The ocean is not empty, it is active chemistry and active physics always interacting with what it touches. Now, compare that with how the ocean usually exists in a human life. For most people, the ocean is experienced in moments: a coastline at sunrise, a ferry crossing, a week on the beach, a wave that makes you feel small in the best way. For some, it's sports and movement, and yes, surfing is part of that for me. The ocean becomes a place where life feels wider, lighter, and more open. But there is another ocean we rarely notice because it doesn't look poetic, it looks normal, it looks like efficiency. The ocean is where goods move without roads, where global trade becomes possible, where supply chains breathe, where ports expand and shorelines are reshaped, where constructions reaches into water, where energy projects appear offshore, where the economy uses the sea as a corridor, a platform, and a connector. And because so much of it happens far from daily life, the ocean begins to feel endless, distant, and untouchable. Like it can take anything, carry anything, dilute anything. Like it will always be fine. So here's the tension that opens this season. Science describes the ocean as a reactive system with slow feedback and long memory. Human life treats the ocean like a silent backdrop with no immediate consequences. The ocean works one way, we imagine it works another way. And when that gap exists, something predictable happens. Anything that doesn't fit neatly into the visible world becomes easier to push away into the invisible one. That is the starting point of this season, and welcome to the ocean of waste. When we talk about the ocean as a system, it helps to pause for the moment and ground the idea in something familiar. Not as a metaphor, and not as a moral comparison, but simply as a way to understand how complex systems respond to what enters them. Because the ocean is not unique in this sense. It is one of many physical and chemical systems on this planet that continuously interact with their surroundings. Most of what humans extend into the ocean today originates elsewhere. Modern infrastructure, energy production, supply chains, industrial activity, all of these systems are designed outside of the ocean. They are created for land, for air, for human environments. When they move into the ocean, they don't become native to it. They enter an existing system from the outside. This doesn't make them unnecessary or wrong. It simply means they are not part of the ocean's original structure. And the ocean responds to them not as uses or project, but as physical presence. The ocean is an active environment. Anything that enters it immediately interacts with the chemistry, temperature, pressure, and motion. Materials behave differently, energy moves differently, effects spread in ways that are not always visible from the surface. To understand this kind of interaction, it helps to look at another system we know well, and that is the human body. The human body is also a physical and chemical system. It constantly reacts to what enters it. Some substances are absorbed and become part of normal function, others are broken down, neutralized, or isolated, and some remain foreign if they don't cause immediate harm. So the key point is not judgment, the key point is reaction. What does not belong to the system's natural processes still interacts with the system. The main difference is speed. The human body produces fast signals like discomfort, pain, inflammation, clear feedback that something does not fit. The ocean produces slow signals. Its responses are spread across distance and time. They accumulate quietly, often far from where the original interaction began. So, when human systems operate inside the ocean, the absence of immediate feedback can look like stability. But in reality, interaction is already taking place. Not because something is wrong, but because the ocean, like any system, responds to what enters it. Whether the signal is fast and visible or slow and delayed. Once we connect human activity and the ocean as a system, one thing becomes clear. Everything that happens in the ocean has consequences for the ocean, not as isolated events, but as a continuous interaction. Infrastructure, energy, transport, tourism, supply chains, all of it operates inside the same medium. Water, pressure, chemistry, motion. The ocean receives all of this together at the same time with one physical system. What makes this hard to grasp is not the scale of activity. It is the timing of the response. The ocean does not respond in real time, it behaves like a large physical system with a memory. It absorbs, holds, and redistributes. What enters the system does not disappear, it stays inside. In physics, systems like this are well understood. Large masses with high heat capacity react slowly. They take the energy, store it, and release it over a long period of time. On the surface, change can look minimal. Inside, accumulation continues. The ocean is the largest example of this on Earth. It stores heat, energy, and chemical change. Chemistry tells a similar story. Buffer systems are designed to hold balance. They absorb disturbance and keep conditions stable, sometimes for a very long time. From the outside, everything appears normal. The system looks resilient. But buffers are not unlimited. Once capacity is reached, behavior changes. What looks stable begins to shift into a different pattern. This is not a failure, it is how such systems work. The ocean combines both properties: high physical inertia and strong chemical buffering. Together, they create a very specific dynamic. Human activity can grow steadily while visible response remains weak. Development continues, movement continues, daily life feels unchanged. Not because there are no effects, but because the system is still holding them. For a long time, this shaped our approach. We acted, observed what we could, and adjusted only when the effects became visible. This logic works well for systems with fast feedback. It fits machines, markets, and processes where cause and effect are close in time. But it doesn't work for systems that accumulate. In a system like the ocean, response always arrives late. By the time patterns become visible, the processes behind them have already been running for years, sometimes decades. This is where the mismatch lies. We did not ignore the ocean, we did not act blindly, we observed. Satellites, sensors, models, and observation systems like Copernicus all play an important role. Monitoring matters. But monitoring alone does not change direction. Observation shows what has already happened. It does not describe where the system heading if currently activity continues. For a slow, massive accumulating system, that difference is critical. Once patterns begin to form, they are no longer local. They spread across space. They settle into the background state of the ocean. They no longer point clearly to a single cause. At that stage, correction becomes harder, adjustment becomes costly, reversal becomes uncertain. This is why the ocean cannot be managed as a reactive system. It requires forecasting. Not forecasting as an exact prediction, but forecasting as understanding trajectory. What happens if current inputs continue? What patterns form over the time? How does the system behave 10 or 20 years ahead, not just next year? These questions are not speculative, they belong to physics and chemistry. The problem is not lack of knowledge, it is lack of application. Short planning cycles and immediate efficiency don't fit a system whose most important responses unfold slowly. So we continued building, moving, expanding, and traveling, not carelessly, not with the intent to cause harm. We simply lived inside a system that was quietly storing the consequences. Now those consequences are becoming harder to ignore, not as a single events, but as patterns, and patterns are the language of the systems. This is where the conversations needs to shift. From reaction to foresight, from asking what is happening now to asking what are we accumulating. Because the ocean does not forget, it holds. And when its internal balance begins to change, the response may be delayed, but is real. Before we talk about solutions, technologies, or policies, there is one thing that has to come first. When you work with any system, you need to understand what that system actually is, how it behaves, how it reacts, and what it absorbs, and what it returns over the time. With the ocean, we often do the opposite. We operate inside it, we build, move, extract, transport, and expand, while treating the ocean as a neutral environment and a background space where activity simply take place. Only later do we begin to measure consequences. This creates a dangerous gap. We act first and then try to understand what we have done. We monitor effects without fully understanding the system that produces them. Part of this comes from a very human bias. We believe we understand the ocean because we are familiar with it. We know it has currents, ecosystems, chemistry, and weather, but familiarity is not the same as understanding. Most of what we use today is short term forecasting, weather models, local observations, point analysis. They are useful, but they are partial. Long term system behavior, accumulation, and trajectory often remain unspoken. Not because they don't exist, but because acknowledging them immediately touches economics, planning, and stability. And so the signals appear indirectly, in delays, in extremes, in patterns that feel disconnected at first. One day systems slow down, supply chains hesitate, weather stops behaving as expected. And only then the question appears, what do we do now? Often followed by another one, why didn't we see this coming? This season starts from that point, not from blame, not from panic, but from the need to understand the ocean as it really is before trying to manage it, fix it, or optimize it. Because you cannot work responsibly with a system you don't fully understand. And the ocean is not a background, it is an active physical system we are deeply embedded in. This is the ocean of waste.